Question 9. A tunnel is 100 meters long. Its cross-section is modelled by y equals a quarter multiplied by 10x minus x squared, where x and y are the horizontal and vertical distances in meters. Using this model, find the greatest height of the tunnel. And we could just use symmetry here to say there's a line of symmetry at x equals 5, so the maximum height would occur when x is 5. Or we could use calculus. Let's use calculus. So we have y is equal to 1 quarter 10x minus x squared. So dy by dx, we can leave the constant at the front, a quarter, and differentiate what's in the bracket. We would get 10 minus 2x. Now for a maximum point, dy by dx will be 0, which implies that 10 minus 2x equals 0, and so x equals 5. Now, to find the height of the tunnel, we need to substitute x equals 5 into the equation for y. So, at the maximum, y is equal to 1 quarter 10 multiplied by 5 minus 5 squared, which is equal to 1 quarter 10 5s are 50, minus 5 squared is 25, 50 minus 25 is 25. So that's 6.25 meters high. Next part of the question. Explain why 100 times the integral from 0 to 10 of y dx gives the volume in cubic meters of the earth removed to make the tunnel, and calculate this volume. Well, we've got a cross-section, and that's the area under the curve. So that is the integral of y dx from 0 to 10. The length of the tunnel is 100 meters, and we get the volume, because it forms a prism, we get the volume given by the cross-sectional area times the length. So we just need to say that the volume is equal to the length times the cross-section. And that will justify what we're going to do now. We're going to evaluate 100 multiplied by the integral from 0 to 10 of y dx. Now y is the quarter bracket 10x minus x squared, so I can bring the quarter straight to the front. 100 multiplied by a quarter is 25, so we get 25 times the integral from 0 to 10 of 10x minus x squared dx. And that gives us 25 multiplied by integral of 10x is 5x squared. Integral of minus x squared is minus x cubed divided by 3. And that has to be evaluated between 10 and 0. So that's equal to 25, 5 times 10 squared minus 10 cubed over 3. And then when we evaluate it at 0, we'll just have 0 minus 0 in the second bracket. Stick that in the calculator, and it comes out to 4,167. and the units will be meters cubed. Now in this part of the question, we're asked to use the trapezium rule to get an estimate for the area under this new tunnel when it's been reshaped. And the volume of this tunnel will again just be the area of the cross-section multiplied by the length. So let's set about finding the area of this cross-section using the trapezium rule. The area is equal to h over 2, where h is the width of the strips. And now we want y0 plus 2. Now we're having 5 strips in total, so all the internal y values are y1 plus y2 plus y3 plus y4. And then we want the last one on its own. The outer y values are only counted once, and all the internal ones are counted twice. Right, so we evaluate that. The strips we can see is 2 meters wide, so we've got 2 over 2. And then in here, the first y value, y0, is 2.15 plus 2 times, and then we've got 5.64 plus 6.44 plus 6.44 plus 5.64. That's all the internal ones, and then finally the last one on its own, 2.15 again. When we put that into the calculator, we get the value 52.62 meters squared as our estimate for the area. So the volume is the area of that cross-section multiplied by the length of 100 meters. It's 56.62 multiplied by 100, which is 5,262 meters cubed. And the final part of the question says, hence estimate the volume of the earth removed when the tunnel is reshaped. So basically the extra earth removed is the difference between this answer and the one on the previous page. So it's 5,262 minus 4,167, which is equal to 1,095 meters cubed.